Hello everyone, my name is Timothy Lee Grant, and today we are going to be doing this problem, number 463, Island Perimeter. So I actually attempted this problem yesterday. I did a video on it where I was seeing this question for the first time, and I was unable to solve it. Not able to get it, but I had to look at the solutions. I tried to put it into my head, like what's going on, where did I make my mistake, how do I improve, how do I understand this problem? That was yesterday. So now today it is the test. Let's see if I can remember how to solve this problem. So it's been about 24 hours. I haven't looked at this problem since. Now it's now it's test time. Okay, so you've seen the problem before, you've seen the solution. You should be able to come up with the solution again from scratch. So, here we go. Let's try to solve this and let's see if I can do it. So as you can see up here, attempted. We tried it yesterday, failed, but we're going to get it this time. Okay, so now I need to remember this problem. What's going on with this problem? So, number 463, island perimeter. You are given rows and columns, grid, representing a map where grid of ij equals 1 represents land and grid of ij equals 0 represents water. So we're given a grid, and this grid has a whole bunch of different cells inside of it. And each of these cells has either a 0 or a 1. If it's a 1, that means that there's land in the cell. If it's a 0, that means that there is water there. Okay, so grid cells are connected horizontally and vertically, but not diagonally. So as we can see down here in this example, you could be connected left, right, and up and down. But let's say that there was land right here. That would not be connected. But there's one other thing that actually there wouldn't be allowed to be land right there. And that is somewhere else. Like the grid is rectangular. This sentence. So the island doesn't have lakes. So what this means is, for example, I can't have land surrounding this and just water right there. Does that make sense? Like, there's no lakes, meaning a body of water surrounded by land. Okay. And then it also says, meaning the water isn't connected to the water around the island. So that's what a lake is. One cell is length 1, so each side is of length 1. Okay, cool. The grid is rectangular. Width and height doesn't exceed 100, so that's just how the grid is set up. Determine the perimeter of the island. So what I want to do is I'm given some landmass, and I know that this landmass, once I find one area of land, I know that I can reach all other land cells from that area or that cell that I found. So what I mean by this is I come here, and let's just say that I found this land cell first. So I come here, I say, oh, nope, this isn't land. No, this isn't land. Oh, I found this one. This is land. So I found one land cell. Now, I know for sure that I can reach the entire island's landmass through this point. So this point is connected to all the other land masses by either going up, down, left, or right, and that qualification can be found. There is exactly one island, right? And one or more land cells are connected. So you're not going to have a land mass here in this cell. All this is water right there, and then you have another land mass out here. So that's not connected. So we know that once we find one land mass, Bam. All we have to do now is depth first search. But the question now comes like, okay, well, great, we can do a depth first search on this landmass. Well, how do we actually get the perimeter, right? Because look at this cell right here. This cell adds 3 to the perimeter. 1, 2, 3. But this cell, this landmass, adds 0 perimeter. So the way that I'm going to go about solving that problem is I'm going to, each land cell that I visit, I'm going to check up, down, left, right. Okay. Then what I'm going to do is I'm going to say, if I check up and I see water, I say, okay, cool, that is part of the perimeter. So I'm going to add to the perimeter. If I go this one, I look left, there's water, so I'm going to add 1 to the perimeter. I'm going to look down. Okay, I see water. I'm going to add 1 to the perimeter. Then this one, what am I going to do? So I'm going to look up, and I'm going to see that it's land. So I'm actually just going to add this value, or this grid point, to the stack, because I want to visit it. But then I'm going to keep looking. Okay, so I look this way, and I say, well, no, that's water, so I add 1 to the perimeter. I look down. Is there land? Nope, there's water, so I'm going to add 1 to the perimeter. Then I look to the left, and I say, oh, there's land. But this one we've already visited, right? So we came from this one to this one. So I'm not going to re-enter that land. I'm just going to say, oh, I've already visited that. So then I'm going to go up here, visit this one, and then say, I look up. Okay, that's land. I'm going to add that to my stack. I'm going to look right. I'm going to say, okay, I see water. So that I'm going to add 1 as perimeter. Then I'm going to look down and say, oh, I found land, but I've already visited there, so I'm not going to go and re-add that to my stack. Then I'm going to look right, or left, and then I'm going to say, I see water, so I'm going to add 1 to my perimeter. So to start off this problem, let us declare a perimeter variable. So perimeter equals 0. Okay, so now if there's no grid, so if not grid, then we just return and then 0, because there's nothing, there is no landmass, so there's no problem, or there's no perimeter. There's no problem either. Just return 0. I like that case. Anyways, so now what are we doing? So I need to first find a landmass. So what am I going to do? I am going to iterate over this grid. So the reason is because I can't just start my depth first search at 0, 0, because, well, look at that. That's not a landmass. Okay, that doesn't make sense. So what I want to do is I want to visit each element in this grid until I find a landmass. Once I find a landmass, I just want to add that to the stack and then pop out, because I'm like, okay, cool, I found a landmass. That's where I'm going to start my depth first search. So I'm going to come here, and then I'm going to come here and then say, oh, I found the landmass. I'm exiting. So I stop searching for land masses. I just add this one to the stack. I get out of that for loop. And then I start my depth first search. So let's write that portion right here. So first I'm going to declare a stack. So let's see, I can just do stack, right? Yeah. I was just making sure that that was not like a keyword or some Python protected variable name. So, I also like to do rows and then columns. So this will equal, rows will equal the length of grid, and then columns will equal length of grid indexed at 0. So at this point, we are guaranteed that we're able to index this 0th element because I've already checked here to say, like, is there anything in grid? If there's nothing in grid, okay, then I can just return. But if there is something in grid, okay, well, then I can obviously index the first element in that array. Makes sense? Okay, so now we are going to search for our first landmass. So I'm going to iterate for I in range of rows, and then for j in range of columns. And then I'm just going to keep checking, like, hey, is this a landmass or not? So if grid I j equals 1, so in this case, if it equals 1, we found the landmass. So what do we want to do? I want to add this. I want to add that coordinate to my stack. Okay, cool. So let's do that. So stack dot append, and then how do I want to store those coordinates? I want to store it in a tuple, so I'm going to do I and j. Okay. Then I want to break out of this for loop, and then once I break, what's going to happen? It's going to send me up into this I for loop. So I have two for loops. I have a j for loop, which is right here. I have an I for loop right here. So if I find this grid that equals land, I'm going to break, but then I'm still going to be in this I for loop, which will look at the different rows. So I'm just going to go down to the next row and then go right back into looking for columns. That's not what I want. I want to say, okay, well, if I found something, I just want to completely break out of both of these for loops. I don't need to keep iterating through this grid. So I can check, like, if, and then stack, then I break again. So what this is going to do is if I have an element in my stack, I'm just popping out and I'm breaking out of this for loop. So cool. At this point, I have something in my stack. I have found a landmass. I found an anchor point from which I can start to perform that depth first search. It could be this landmass. It could have been this landmass. Now, in my implementation, it's going to start here and then go to the next column and next column and next column. Then it's going to go here. So it's going to traverse this grid in that fashion. So it would always end up in this, on this particular cell. But I could have done it in such a way that it started in this cell and just came and found this one. So all I need is an anchor point from which I can start my depth first search. And I have that. It's in my stack. So now, performing depth first search. So I am going to, okay, so I have my stack. I know while stack. So while there's still an element in my stack, I'm going to keep iterating, and I'm going to stop iterating once my stack is empty, which means I have no more unvisited land masses that I need to still visit and check and accumulate values into my perimeter variable. So, okay, so wall stack, I want to get current like location, but that's kind of a long variable name, so I'm just going to call it cur equals, and then stack dot pop So I'm going to take the first element off here's the stack, and right now there's one element in it. So I'm going to take the element off, so now there's nothing. And then I'm going to look at this anchor point, which I said is right here, and I'm going to see all of the connected land masses. So I'm going to look up, I'm going to look right, I'm going to look down, I'm going to look left. And if I see land, I'm going to add that to my stack. If I see water, I'm going to add to perimeter. I'm going to add 1 to perimeter. Okay? And then I'm going to come back up and look at my stack, and then I'm going to say, okay, well, I found this this grid point that was in my stack. So now I'm going to pop from my stack. I'm going to look up, and I'm going to say, I already visited that. I already visited you. I'm not visiting you again. So I'm not going to put this in my stack because I've already been there. Then I'm going to look right. And I'm going to say, okay, I haven't visited you, and you are land, so I'm going to put you in the stack. Then I'm going to put this in the stack. Then I'm going to put this in the stack. And then next iteration up, stack now contains this and this and this. Okay, so now I am going to go to, and because this is a stack, it is the most recently seen. So I'm actually going to visit this element. I'm going to look up. I'm going to see water. I'm going to add 1 to perimeter. I'm going to look to my right. I see this one. I've already been there. I'm not going to add you. I'm going to look down. I see, haha, water. Add 1 to the perimeter. Nice. Then I'm going to look left and say, okay, water. I'm going to add 1 to the perimeter. Then I am going to go back up to the next iteration of this while loop, and I am going to say, okay, I'm here. Or no, sorry, I'm gonna pop my stack, where was the second to last element that I saw from this one. I saw this one, and then this one. Then I visited this one. Now I'm gonna go visit this one because that's the most recently seen element. Okay, so I visit this one, I do the same thing. I already saw you. Water, add 1 to perimeter. See you, put you in my stack. You're going to be the next one that I visit, right? Because in depth first search, you use a stack because you want to visit the most recently seen node, or like area, or in a binary search tree, it's a node, but in this case, it's grid point. So you want to visit the most recently seen because you want to go depth. You want to go as far down as possible. And so you keep, you're going to come here, and then you're going to come here, and then you're going to go there finally. Okay, so all that talking, let's get to coding. So current is, so I have current, which is the current element that I am investigating. So let us look up, down, left, right. And this is one of those things that I vaguely remember from the solution that I saw yesterday, which was we had to declare we did something like direction, so dr, di, was it di, dj, was it for di, dj in, and then a list of tuples. Okay, so in this tuples, we had the 4 directions in which we were allowed to go. So we had 1, 0. So right now, what I'm trying to do is create a list um, which contains the the combinations of directions in which we can look. So we can, this one represents +1 in the x direction and 0 in the y direction. So, or the I direction and the j direction is the way that I have it here. So that means I is going to be row, so I'm going to be looking up, but the same column. And then in the next one, I can do like -1, 0. So this is representing looking down. So you decrement I by 1 and look down. And then we can do the same thing with columns. So increasing column and decreasing column. And by the way, I just realized I kind of said this wrong. This +1 actually corresponds to looking down. And the reason for that is because this is the 0th row. This is the 1th row. This is the 2th row. So by increasing the row value, you actually look down. And then this -1 is going to be looking up because this is the -1th, which doesn't exist. So it's going to be outside the bounds of the array. Okay. So now the other thing that I am able to do is look to the right, and this would be looking to the left. Okay, so I now have these directions that I'm allowed to look at, and then I'm going to be iterating through all 4 of these directions, and I am going to now have di is going to be either 1 or 0 or -1 based off of each time I iterate through. I'm going to get, like, for example, the first time I iterate through this list, the first iteration of this for loop, I'm going to get this tuple, and so di is going to be 1, dj is going to be 0. Then the second time I iterate through this list, I'm going to get this tuple, so di is going to be -1, dj is going to be 0. So I'm going to keep saving that variable into this di and dj variable, and then based off of that, I can say where I currently am, look up, look right, look down, look left, and then do my logic based off of that. So let's take a sip of coffee and then start working on it. All right, so what do we want to do with this? I need a haircut. So what do we want to do with this? I remember from the problem, what we had to do was we need to find the actual location, which we're... So how do I determine the location? That is grid. So I'm going to go... So the reason I'm hesitant is because I can't do something like grid of cur. Okay, hold on. I need to think a little bit about this, and then we will get back to our regularly scheduled program. So let me think. Okay, this stack is going to contain a tuple. It is going to contain I and j. So actually, I want to grab the I and j value. Okay, so what I'm saying right here is the stack contains, and I said that I was going to store the grid location in this format where it's a tuple, and it contains the I, which means the row value, or the row index, and the j, which contains the column index. So I'm just going to capture that. I'm going to pop, and I'm going to get the I and the j. Okay, but I cannot do something like this. So now I can do I plus di. No, I can't. Why? Think about the case where this I, right here, this is the 0th row and the first column. So I is 0, j is 1. Okay, cool. I iterate through this one. There is no problem, right? Yeah. This one, there is a problem. Why? What's going on? I'm doing 0. I is 0. Now I add -1. I am trying to index this element. Problem. Right there. There's our problem. So I can't do that. So I need some way of blocking this, but the way that programming languages work, if I do like a chain if statement, like a if something and something and something and something, the way that the program will work is in an and statement, if one of those clauses is found to be false, it knows that it doesn't even need to look at the other clauses because the statement is going to be false. So what I can do is I can say like if I plus di is less than 0, or okay, so I'm in an or case, it will check the other ones. Okay, so I am trying to get, let's see, would it be, it's greater than 0, so if it's less than 0, what if I do like this? If, and then if not this, I don't like this complicated statement right here because it's prone to errors and it's not very readable. Like if not something and if not something else, it just doesn't feel like nice. Hold on, I might need to come and maybe clean this up. It's definitely one of those things that I saw yesterday, but I'm a little bit, I need to think about this. I don't know how I feel. I don't know how I feel about this. But I do know I need some extra superpower. All right, let me kind of reset. What am I even trying to do? I'm gonna do something. I'm gonna have this like thing, and I want to essentially this is going to be my base case, right? Of I guess this is going to be my case where I hit water. The reason why it would be the case that I'm hitting water is because if I'm outside outside the bounds of the array, I know that all of this is going to be water up here, so I know that I'm hitting water. So if it is if in visited, okay, so in this case I just want to continue. Okay. Now this is the case that it hits water, so I want to check if it's outside the bounds of the array. So if I plus di is less than 0, or j plus dj is less than 0, or I plus di is greater than, and I'm curious about this, equal to. That's obviously not the right syntax. That means I'm having a question mark right there. Rows, or j plus dj is greater than equal to calls. Then I know that I'm at a water boundary, right? So I don't add anything to the stack. I don't add anything to the stack, yeah. Or, and this is what I'm kind of concerned about, I plus di, j plus dj equals 0, then I am needing to just add 1 to perimeter. So perimeter plus equals 1, then else if grid of, so right now I'm just trying to think like, is this actually going to work? And then I will kind of explain what I am doing. So 1, then I want to add that element to my stack, right? So stack.append, and I want to append a tuple, and in that tuple I want this and this, my tuple. Okay, I think this will work. So what I'm trying to do is I want to guard, so I'm looking in each direction. I have my current element that I'm at. So this I and j is where I currently am located. I want to look up, look right, look down, and look left. And each time that I do that, that corresponds to one of these cases. Looking up is corresponding to this case, looking down is corresponding to this case, to the right and to the left, as I've discussed before. So I want to go through each of those, and the way that I can do it is I have my grid point right here, I and j, that's how it's represented, and it is going to be, for this one, I is going to be 0, j is going to be 1, and then I have this di dj, so that is going to be like, okay, if I'm looking right, I want to see this cell right here, and that is going to be, I is going to be 0, so there's going to be no change to 0 to I, because it's going to be the current element where I equals 0, where I currently am, and where I'm looking, I is the same. So the change in I is going to be 0. The change in j, meaning the column, is going to be plus 1. So I'm going to try to look at this, and then I'm going to see a few things. So I'm going to try to see if it's water. And now the question is, okay, if it's water, I know what I need to do. I need to add 1 to perimeter. But I can't necessarily know that I am allowed to index the j plus 1 element in the grid, because think about the case if this was land. Okay, if that was land, all of a sudden I add 1, my dj value is 1, and my j value is 0, 1, 2, 3. So now all of a sudden I'm trying to do grid of 0, 4. And that's going to give me an error. It's going to say, no, you can't do that. So that's why I'm worried about this line of code right here, because I don't want to index outside of the bounds. Now, what I'm thinking is, in this statement, I'm hoping that one of these will catch it, and if it does catch it, then it will not continue to check all of the other cases. So for example, because all of these are ORs, if one of them is true, once one is found to be true, all of a sudden I don't need to check all of the other ones. Does that make sense? So I put this element last because I don't want, if this is true, if my I plus di is less than 0, that means I'm looking here. I don't want to index that and try to get that in my grid because I'm going to get an indexing error. What I want to do is just say, okay, I know that looking to my left from this perimeter, or from the outside of the bounds, I know that that's water because that was defined in the question. So therefore, all I want to do is I want to say that it's water. I want to add 1 to the perimeter. Okay, so now, then, if none of these are true, okay, well then, I'm not outside of the perimeter. I'm not looking outside of the perimeter. I'm never outside the perimeter. So this is my current location. This is where I'm looking, right? So if I am looking outside of the perimeter, then it's going to hit this case, one of these. Then if none of those hit, I know, okay, I am not looking outside the perimeter right now, so I am safe to index it. And if it's equal to 0, then I know, all right, it is a water element. For example, right here, I'm right here, and I'm looking right here. Okay, I know that I'm looking at water element. That means that this border is a perimeter, a +1 to perimeter. Cool, so I'm going to do that. Now this else case, that means that this if statement didn't hit. So I am not outside, I'm not looking outside the bounds of this grid. I'm currently on some land, and I'm not looking outside the bounds. And I'm not looking at water. So what is that? That must be that I'm looking at land. So I actually don't even need this else, or I don't even need this if right here. But this just makes it, I wanted to write that to just be explicit, and then I can take it away later. So I don't even need this, but this is what the case is doing. I'm checking if it's land. So I'm going to get rid of that. So else, what do I want to do? I'm looking at land, so I want to add the land that I'm looking at to my stack because I need to still investigate it. Okay. And now let's talk about this right here. So when I am at a location, I'm going to be looking somewhere. Let's say I'm looking right here. I am right here, and I'm looking right here. Okay. And let's say that I've already been here. So I came here, came here, came here. Now I look up, look to my left, look down, or sorry, look to my right, look down, then look to my left. And I've already been here. I want to just say like, okay, this landmass is already in visited. I've already visited this landmass. What do I want to do in that case? I just want to continue, which that means I'm going to not do any more of the rest of this for loop right here. I'm going to come down here and just go to the next iteration of the for loop, which means that I'm just going to be grabbing, if I was in the first tuple, I'm just going to say, okay, well, I'm not going to do the rest. I'm going to come back up to this for loop, and I'm going to get the next tuple. So it just means like the land, or the area, the direction that I'm looking at, I've already visited it. That means I'm not interested in this landmass. I don't want to add one to perimeter, and I also don't want to add it to stack. I've already seen it. Okay. Now, the question that I'm having is, do I always add everything that I look at to the to the visited set? So this is going to be a set. So I'm going to have tid equals set. Okay. So do I always want to add it to the set? No. And the reason is because let's say I'm here, I look to my right and I see water. Okay. And then I come down here and I look up. Well, this is the same cell, but I want to add water, or I want to add perimeter, and I want to add perimeter. So I don't want to just immediately like pop out at that point. I want to perform that operation, and I want to say, yep, that is water. So I'm going to not add it to my stack. Sorry. That is water, so I do want to like add one to perimeter. I don't want this to be in my visited, because all I'm doing is looking, like visited is the land that I have currently gone to, and then I look in each of those directions. So what is that? That means, okay, that would be this, right? So or is it add? And then a tuple I and j. Okay, so this while loop, this big while loop, is I'm going to each of those land masses. I'm coming here, then I'm coming here, I'm coming here. This for loop is looking in each direction based off of the like location that I am. So if I'm right here, I look up, I look down, I look left, I look right, I do that. But my I and j are right here. So when I go from this element to this element, I want to add this element to my, each time I go to a landmass, I want to add that to my visited set, and then I can look and see what I see. Okay. Does that work? Wait, if and then IDI. So if this element that I'm looking at, I've already been to, then I just want to continue. Dot add. Oh, it doesn't like my add. Oh no, it doesn't like visited. Hold on. Visited? Oh, no. No, 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 no. Oof. Oof. Okay. So apparently, and this is an easy problem, guys. This is an easy. This is like if you want to feel really dumb, just do LeetCode. Like LeetCode crushes your ego like nothing else. An easy problem. And I saw that answer yesterday. I investigated the answer yesterday. I spent like an hour and a half trying to do this. Darn. See all submissions. You can see like yesterday. Bam, 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 bam. And I don't really know why. Because I think that this should work. Well. So. I'm not even sure how I would go about debugging this, though, to be honest. Like, the test case that it failed for. Let me just do run. Let's see if it does it for any of the run cases. So it passes all of those run cases. So I think I'm on the right track. It's just like an edge case, but I don't necessarily see what the edge case is that it's failing for. Like, I think it said 1 1 and 1 1 or something. Hold on, let me just see if I can do this and if it pops up like what it failed for. 1 1 1 1. How? What? That doesn't. Wait. Okay, hold on. 1 1 1 1. Oh, I see. So this is a grid. So the row, column, row, column. So there is 4 grids, okay? Each one is land, okay? Okay, so I can visualize it kind of in my mind. So now I'll try to go through the code and see where things would fail. And we're out of coffee too. So I have 4 here and here, so like this, right? All of them are land. And as expected, it's going to be 8, which is the perimeter. So I'm going to be looking up, and that's going to be, so on the first element, so 0 0, this. So it's going to be a grid of 4, okay? And all of them are land, and then all of this is ocean. All of that is like the perimeter. So I have these four here. All of them are land. Everything else is ocean. So I find that this is land. I look up. I see that that's outside the bounds of the array. So I should add 1 to perimeter. Then this is land. So I add that to my stack. This is land. So I add that to my stack. This is outside the bounds of the array, so I add 1 to perimeter. So I have 1 and 1. And then I go to this one. I look up, and that's in visited, so I don't do anything. I look right, and this is land, so I add it to my stack. I look down, and I see that this is water, so I add 1 to perimeter. I look left and I see it's outside the bounds of the array, so I add 1 to perimeter. Then I go to this element. I look to my left. I see that this is already in visited, so I don't do anything. I look up. I see that this is land, so I add it to my stack. Then I look right and I see that this is outside of the bounds of the array, so I add 1. This is also outside the bounds of the array, so I add 1. Then I come up here and I look up, outside the bounds, add 1. Outside the bounds, add 1. Already visited and already visited. So then I terminate. So in total, I have 1, 2, 3, 4, 5, 6, 7, 8. The perimeter is 8, which is, in the problem, that's what it said it expected. But somehow I returned 10. Okay, so that's kind of the clue that we have to work with as to why this test case failed. Okay, so I'm just going to assume that yes, we did find this. Okay, so while stack. So perimeter is 0, yes. Okay, so while stack, okay. So I am going to every time I arrive at land, I immediately add it to visited. Okay, so that's important because what I am thinking is maybe I'm going to land twice, the same land element twice, and I'm re-adding those two oceans, and that is the way that I'm getting 10. That's what I'm thinking. So I get to a land element, and I immediately add it to visited. Okay. So then I come here, and I just am going to look up, down, left, and right. Okay. So now I say, okay, let me see if that direction, which I am looking, the cell that I'm looking at, is already in visited. Okay. If so, I continue to look, but I don't do anything. But I'm not going to do anything with that direction, right? Unfortunately, this one is not coffee. Non-caffeinated, it's tea. Come on. Okay. So, the direction which I'm looking at, if I've already seen it, what's the I just exit out of that direction. I stop looking at that direction because I don't want to keep looking in that direction. I've already visited it. And if I visited it, it means that it is land. So it's not ocean, right? Because I can't visit ocean. I can't go to ocean. Okay. If it's not invisited, that means that I have not been there before. Okay. So in that case, what do I want to do? I want to check if it is water. So what defines water? It is outside the bounds of the array. So if it is this, or if it is this, or if it, wait, hold on. I, J, darn. I thought I was onto something. I thought never mind. Never mind. So, is it possibly something with this right here? So let me think about this. So rows is going to be the number of elements. And now this is going to be the indexes added, right? Okay, so let me think. So I have I, which equals so I is going to be 0, 1, 2, 3, right? And then di is going to be equal to 1, so now I'm at 4. And now length of rows is going to be 1, 2, 3, 4, right? Which that makes sense because I want I'm at the third index and I add 1, so I'm at 4. So I say the number 4. This evaluates to 4, and then that is equal to this. If this is equal to 0, okay. Man, I feel like a terrible, 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 terrible software engineer. So originally I was planning in this video to quickly go through this solution and just get it, because I was hoping that I would be a little bit more intelligent than I actually am and I would actually be able to pull it off. And then I was like, okay, cool, we got it, we succeeded, let's do the recursive depth first search that we also saw, because I searched both the iterative and the recursive solution, and I was like, let's practice both because this is a great practice problem. It's an easy, we saw it yesterday. I didn't expect what I really should expect based off my track record of constantly failing at every single thing that I do on LeetCode. I should have expected this to be the case. Well, I don't know. I don't know in insofar as like I don't know how to solve it, and I also don't know as in like I don't know if I want to continue doing LeetCode. I don't know. I don't know to both. This sucks. Well, this is an easy that I saw yesterday. And I completely can't solve it. It I real and I've been doing specifically depth first search for like a week and a half or 2 weeks now. Like every single day I've been focusing on getting competent in depth first search, and I still can't do this. I really feel like I'm not improving. This is so unfortunate. Why? What? Where? Why? And I should also be able to troubleshoot it. Like that's a basic skill in coding is to be able to troubleshoot it. And I'm looking at this and I'm just like I can't, I don't know. I don't. And then if it's not one of those, I just add it to the stack. And then I just pop from the stack. Come on. Come on. Submit, 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 submit. Go. Speed up. Go. Wrong answer. I don't care. Go. 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 Yeah, it's correct. It's correct. It's correct. I hate this. I hate this so much. Go. Go. It's correct. Go. An easy problem. Easy. And this is an easy, like it's not just like labeled easy. This is an easy problem. This should be something that is simple for me, but it's not. I can't do it. I'm too stupid. I fucking hate this, man. I fucking hate this. I'm too fucking idiot. Yeah, There's a slight You should check if the cell is water. I fucking did. And not already visited. What? Why does that work? What's... Tell... Where's the difference? It's less than 0 is less than 0 is less than 0 less than 0 greater than or equal to rows greater than or equal to columns, or if they're the exact same. Grid of I and j equals 0. Wait, what? For loop where you iterate over the neighboring cells to check if they are water or out of bounds. Why? So it looks like this. I don't know, man. I don't know. I'm just gonna hashtag that out. I don't know. I don't think this question must not be possible. This isn't a possible problem. Damn it. Damn. Fuck you. Fuck you.